Hello, this is Mario from ODEON. In this video, we will talk about movie auralisation, available in editions Auditorium and Combined. Movie auralisation allows you to listen to an auralisation while moving through the room. Here, the red sphere is the source, so pay attention to the sound when passing next to the source.
The Athenian agora had a soft slope. It was during the 5th century before Christ that the Athenian agora began to take shape as the commercial and civic center of Athens. Before the middle of that century, the center of public theater activities was moved from its temporary location in the agora.
To do this, you define a fixed receiver path. ODEON will then compute the auralisation following that path, and exports the experience into an MP4 video file that can be shared to anyone. The auralisation is binaural, so the viewer only needs headphones. Due to the MP4 compression, a 2-minute video can be small enough in size to share even by email, depending on your settings. And if you have defined visual assets, they can also be included in the movie auralisation. You can check out various examples of movie auralisations produced in ODEON on our website odeon.dk. Examples. Movie auralisation examples. To create your own movie auralisation, first you must define a mix. We explained the procedure in our main tutorial on producing auralisations. The movie auralisation can take some time to calculate, so before generating it, we recommend to calculate just the mix and listen to it to make sure it sounds correct. Next, select your mix and click on this icon. Here, you only need to define a few points along the desired path, which we call keyframes. ODEON will then generate a receiver path which goes through these keyframes. You can create a keyframe by clicking this icon. To edit the position, you can either click twice on any of the coordinate columns, or you can double-click on the keyframe in the 3D view. This brings up a blue grid for positioning, just like when defining sources and receivers. As a reminder, you can Ctrl-click to place the point at the grid intersections, you can drag and drop to place it anywhere in the plane, and you can rotate the model to change the orientation of the plane, which lets you position the point along the remaining third axis. You can also set a point at a distance relative to a surface in the X, Y, or Z direction, just like you can with sources and receivers. This is especially useful to set the height of the point, which is an alignment in the Z axis. You can view the 3D render of the model from the selected keyframes perspective with this icon. This 3D render also allows you to reposition the keyframe by using the up and down arrow keys, or dragging with right-click. Each time you create a new keyframe, it will be placed at the same position as the currently highlighted keyframe, so you will need to reposition it. Once you have at least 3 keyframes in different positions, ODEON will interpolate a path between the points. You can move and rearrange the keyframes at any time, and ODEON will always calculate a new interpolated path. To move a different keyframe, you must first select it by clicking on it in the 3D view or in the keyframe list. You can move the selected keyframe up and down the list with these icons. You can also delete keyframes with this icon. And you can reverse the order of all keyframes with this icon. Again, movie auralisations can take some time to calculate, so another recommendation is to preview the receiver path before running the calculation. The preview will start at the currently highlighted keyframe, so we recommend to first highlight the first keyframe. Then, open the video preview with this icon. This will look similar to the 3D render view from Keyframe, so make sure to look at the title and the hint in blue text to identify which of the two 3D render views you're currently in. The video preview will also have a blinking red dot at the top right corner of the window. Here, you can use the up and down arrows to move along the path. This will move you through the interpolated path, not just the keyframes themselves. In the 3D view, the red X will show your current position in the 3D render. You can hold the up arrow to go through the whole path. Keep in mind that the movement speed will not necessarily be the same as in the output video. Notice that the camera's facing direction will turn automatically according to the path. Currently, it is not possible to manually set a facing direction. By default, the camera's facing direction will only turn horizontally, while keeping the vertical angle at 0 degrees. Alternatively, to allow the vertical angle to change as well, you can untick the horizontal view checkbox. Just like the horizontal direction, the vertical angle will change according to the path. So, it will look like a roller coaster ride. Most typically, the horizontal view gives a more natural feel. You can store several receiver paths and switch between them. First, let's add a description to our current receiver path. Then, create a new receiver path with this icon. You can then create a new set of keyframes. You can switch between saved receiver paths here. You can also duplicate the current receiver path or delete it. Now, let's look at the 3D render settings. These checkboxes will enable and disable certain elements to be rendered in the video. You can toggle whether active sources will be visible, that is, sources that contribute to the currently selected mix. Inactive sources will never be included in the video. You can also toggle receivers. Assets are 2D and 3D objects you can place in the room for visual purposes. They can be placed anywhere in the model or assigned to sources and receivers.
The Athenian agora and the south slope. It was during the 5th century before Christ that the Athenian agora began to take shape as a commercial and civic center of Athens.
We explain how to configure assets in a different video. If you disable assets, standalone assets will simply disappear, while assets assigned to sources and receivers will be replaced with a red or blue sphere respectively. The X-ray checkbox makes the surfaces see-through. The black background checkbox will replace the 3D render background with a solid black color, just like when pressing the B key in the 3D render. This dropdown allows you to select which colors will be set on the surfaces. If you select material colors, the surfaces will show the colors that are automatically generated by ODEON to represent the material's absorption curve. This is useful if you want to be able to tell the acoustic behavior of a surface at a glance. Interpreting the meaning of material colors is explained in our video on setting absorption and scattering. If you select layer colors, the surfaces will show the color of the layer they belong to. Remember that you can change the color of a layer to the color of the material in real life. Changing layer colors is explained in our video on the 3D view and 3D render. If you have done this, then the layer colors option is useful to make the room look more like the real room in terms of colors. When repositioning a keyframe in the 3D render or going through the receiver path in the video preview, you will get a warning when too close to a surface. The 3D render window will get a red outline, and a message will show for a few seconds. The distance from a surface which triggers this warning is the collision detection distance parameter. The traveling speed is how fast the camera moves along the receiver path. The default of 1.4 meters per second is around the average human walking speed. With the current setting, here you can see how long it takes to go through the whole path. Often, this will not be the same duration as that of the audio signal. With this icon, ODEON will set the required traveling speed to equalize the travel duration and signal duration. If this results in a traveling speed greater than 3 meters per second, the video might look uncomfortably fast. In that case, we would recommend using a longer audio signal. This checkbox, Stop Movie at the end of the path, is mostly relevant when the signal duration is longer than the traveling duration. Without this option, the video could reach the final position in the receiver path and then just sit there while the signal is still playing. This option makes the video end as soon as the final position is reached, regardless of whether there is still audio to play. Finally, here you can specify various settings for the video file, these being the frame rate, aspect ratio, orientation, resolution, and audio compression quality. If you need the final video file to be small enough to include as an email attachment, you can always play around with these options as well as the traveling speed. Here's some examples of file sizes with different parameters. These were all generated with an audio compression quality of 192K. Notice that doubling the length or the frame rate does not necessarily double the file size. This is due to how MP4 compression works. Compared to these parameters, audio compression quality does not have a big impact on file size. In general, we recommend to use an audio compression quality of at least 192K. You can switch to a different auralisation mix here. When ready, click on Generate Movie, which will create the video file. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!